In this section, we will review the Cox proportional hazards model. The Cox proportional hazards model is a commonly used model to investigate the association between a patient's survival time and one or more predictor variables. The advantage of this model is that you can include both continuous and categorical variables as your predictors, and also so you can assess multiple variables at the same time. One of the assumptions, however, because we're looking at time, is that the hazards will remain constant. And so we have the proportional hazards assumption for this model. What is a hazard? A hazard is the instantaneous risk of failure, given that the participant has survived up to that point. So the interpretation of the hazard ratio is very similar to the odds ratio, except that in this case we are looking at hazards instead of odds. So if the hazard ratio is 1, then you have the same hazard among the exposed and unexposed. So the numerator and denominator, the hazard for those will be similar. If the hazard ratio is greater than 1, then the hazard is higher among the exposed than the unexposed. And the unexposed will be your reference, will be in the denominator, whereas the exposed will be in the numerator. If the hazard ratio is less than 1, then the exposed have a lower hazard compared to the unexposed. So the interpretation is very similar to the odds ratio. And again, because we're looking over time, we need to think about, instead of just a single time point, we think about the hazards over time. And this relationship should remain constant over time. As you can see in this picture here, we have a constant hazard ratio. To the right, the hazard changes. Another assumption that we make is that the censoring that occurs is non-informative. This happens, so that means that the individuals, when they're lost to follow-up, this does not occur differentially in the two groups we're comparing. There are different ways of checking for the proportional hazards assumption. A simple way in SAS to check the assumption is to run the PROC live test with the LLS option. You can see an example here. If the proportional hazard assumption is met, you would see the lines to be approximately parallel, as it is in this case. Otherwise, the lines would cross. That would indicate that the proportional hazard assumption is violated. When comparing the Kaplan-Meier or the PROC live test and the Cox proportional hazards model using PROC PH-Reg, we can see a few differences. Kaplan-Meier, you can think of it almost as when you were doing the Cochrane-Mentor-Hansel and the PROC Freak and looking at tables. So similarly here for time to event data, we can use the Kaplan-Meier for preliminary analysis to test simple hypotheses. However, there are limitations, and we cannot test for interactions in Kaplan-Meier. And also it doesn't handle many different categories or continuous variables. So we can use PROC PH-Reg. This is similar to thinking about logistic regression. So this has more options. We can calculate the hazard ratio, similar to what we could do in logistic regression when we calculate the odds ratio. A nice feature of PROC PH-Reg is that it is a semi-parametric analysis, So we don't need to specify a particular distribution. We can test for interactions. We can add multiple covariates, similar to what we could do in logistic regression. And we can have right censoring. For interval or left censoring, then we would need to consider another analysis. And ProPHREG can actually also be used for conditional logistic regression. So remember when we did the PROC live test for Kaplan-Meier, we were testing for treatment, and we were stratifying on renal function because the hazard function was different in those with and without renal impairment.